So in this video, we're going to use all the fundamental data types that we've learned about so far, right? And we're going to use them in mathematical expressions so that we can start doing actual work in Java. And along the way, we will hit upon a concept known as type promotions. And this is actually a crucial concept to understand when you're dealing with expressions of different data types. Okay, so let's go ahead and start this, right? So as we have been doing in the previous videos, you start your IDE and we'll create a new project. Again, the standard stuff here. Next, I'm going to call this expressions, EXPRXR finish, and this is going to start up. Again, we will just run the project just to make sure that everything is configured properly, and if you get an error, you know what to do. Yeah, so everything compiles fine. So let's just hide this, format this, and now we are ready to go. Okay, so Java, like any other programming language, supports the standard mathematical operators. So again, single line comment. So addition, subtraction, multiplication, division, and remainder. Okay, so we'll see these operators, and we'll also talk about operator precedence. For example, what happens when you have multiple operators in an expression, right? So let's get started. Okay, so let's start with, let's say I have an int a and I give it a value 10, right? Now I have another int b and I give it another value 20, right? And I want to print out the value of a plus b. So I say a plus b, and here if you notice, everything is in alignment. A is an int, b is an int, c is an int, so everything is in alignment. So if I try to print this out, you should see c is equal to c. So let's try and run this, and you should see 30. C is equal to 30, right? So this is simple enough. This also would work similarly for, let's say, the other operators. So for example, if you have minus here, right? So all of this is actually fairly simple. And now there's a reason I started with int rather than byte and short. Okay, so in Java, there's a funny thing that happens when you have a variable of, let's say, a byte or a short. So let's create a byte variable. Let's call it b1 and give it a value of 50. Okay, let's create another byte variable b2 and give it a value of 25, right? And I'm just going to do a simple operation of addition of these two values. So I'm going to say b1 plus b2, right? And now something funny happens here. b1 is a byte, its value is 50. b2 is also a byte, its value is 25. b3 is a byte and it should be 75. But somehow Java is actually telling us that there's an error in this line, right? And what happens here is this second point that we talked about in this, which is called type promotions, right? What's actually happening here is, because you have this plus operator here, and actually it works for all the operators, so not only plus but minus, multiply, divide, remainder, everything, right? Because you have this operator here, what Java does is it takes this left hand operand, which is b1, and converts it to an int. It takes b2 and converts it to an int, or promotes it, right? It takes a lower sized thing, so something which is 1 byte in this case, and makes it 4 bytes. Okay, why? Because promoting up will make it so that the lower one always fits in the larger one. So it promotes it to int, and then the expression actually becomes int plus int on this side. So it actually becomes int b1 plus int b2. This is pseudocode. Okay, so Earlier, these were actually bytes, but now Java has made them ints. So if you look at this, logically 75, which would have been the answer of this, could easily fit in another byte. But because of this type promotion, what you have to do is you have to cast the result, which we learned in the previous video, to a byte. And now everything works out, right? So if I print this out, for example, I would say B3 equals plus B3. I'm going to print this out. And now you see that B3 is 75, right? So this is it's a queer thing. It's a weird thing that Java does, but actually all the programming languages do this. And this is why I wanted you to pay a lot of attention to the videos that came before this, right? As to which which data type you're going to be storing in which variable, how to cast, all of those things were really important. So if you haven't gotten that yet, you should re-watch the previous videos, right? So this kind of type promotion happens every time. So what will happen is in your programs, you may have, let's say in this case, you have a byte B1 and you have a short. So let's create a short, for example, let's say S1, okay, and give it a value of 1000, right? And you might now want to write an expression, which is, let's say, short S2 equals S1 plus B1, right? Again, here you see the same problem. So if you mouse over it, you'll see the same thing. You're expecting a short, which is the left hand side, but you actually provided an int, right? So in this case, it's saying you can cast to short. So I could either cast to short, and then that should work, because a byte could be cast to a short as well, right? A byte would fit in a short. Or I could have actually cast it to in another case, I might actually want to cast it to a different type of variable depending on what is on the left hand side. So here, if I just print this out now, so I'm going to say S2 is equal to S2, run this, and here you have the answer, right? Now, this kind of type promotion stuff is easy to understand when you have just one operator, which is plus in this case, and two operands, right? But sometimes things are not so simple. So let's say, for example, you have a variable which is, so let's say, let's do a small sort of example, right? You want to find the area of a square, right? So the formula for the area of a square is basically pi r squared, right? So what I'm going to do is I'm going to say, I'm going to create a double, I'm going to call it pi, and I'm going to give it a value of 3.14, okay? And r is the radius, so I'm going to say, let's say the radius can only be ints, right? So I'm going to say int r is equal to 7. Now I want to calculate the area, so I say s out. So actually, let me do this first. Let me create a variable. Now, what should be the data type of this variable? Should it be int or should it be double? Okay, so let's do it one at a time. So let's do it with the smaller one first, right? Int area is equal to pi into r into r. That's pi r squared. Okay, now if you notice, again, the IDE, let me just hide this. The IDE is again highlighted it. It says that you want an int, but the value that you're going to get after compiling this whole expression in Java is going to be a double, right? So what Java is actually doing here is Java sees pi, looks at the entire expression and looks for the largest or most precise data type. In this case, it is pi because that's a double, okay? It then takes r and promotes it to a double. It then takes this r and also promotes it to a double. So really what this expression becomes is double pi into double r into double r, right? So this again is not what you expect. So I just wanted to sort of do this video to kind of draw your attention to all of these things. Now, of course, there are two ways of solving this. One is if you say whatever the answer is, cast it to an int. Okay, and let's print this out and see why this would not be the best way of doing it. Okay, so let me run this code and you'll see you get 147, right? But obviously this is 3.14 multiplied by 7 and 7. So the answer actually is not as precise as you can get. You can actually get a decimal point after this 147, but we don't get it here because we've said that we want an int. So what Java has done here is it's actually cast this pi into an int, and now int into int into int has made it an integer value, which is basically what you saw down there. You could also have casted the entire expression by just putting brackets around them to an int. So what would happen here is actually these would become doubles. This is already a double. The result would be a double, and then the result of that double would be truncated. That means the decimal points will be removed and you will get an int. Okay, so in this case, because we want to be very precise, we know that we should get a decimal point as the answer. I'm going to say double, and I'm going to actually knock off all of this, right? So let's run this again now, and you'll see you get an answer which is the most precise that you can get based on the inputs that you've given it. Okay, so this is how expressions work. So I'm not going to do examples of every single expression. That is left as an exercise to you guys, but I wanted to show you what these expressions were and why it is actually a little bit complicated, right? So in the last example today, what I'm going to actually do is I'm going to show you an example of where even if you don't, so if you are not careful with this type promotion, and if you're not careful with the data type you use, or if you're not careful with the casting, right, you can hit some serious problems, right? So if I say int num equals, and I'm going to say 100, sorry 1000, okay, and I'm going to multiply this by 100,000. Okay, now let me just try to print this out. I'm going to say num is equal to plus num. So this actually works out. Let me just add a few zeros here. These are still valid numbers for ints. Now notice something, right? I've given it a number here, which is, what is this? 1 million. Okay, so I've multiplied 1 million by 1 million. Let me just put these in the correct places. So I've multiplied 1 million by 1 million. This by itself is an int. So let's do this. The first one is an int. The second one is also an int. 1 million is also an int. But when you multiply the both of them, you will get a number which is much larger than 2 billion, right? Which is the maximum number that you can store in an int. So what has Java done? Instead of throwing an error or telling you that there's an error, basically Java has highlighted it. And if you see things which are highlighted, if you just mouse over it, it tells you numeric overflow in expression. Now, if you remember from the previous video, when you have a number that overflows what can fit in that particular data type, it actually wraps around and goes into the negative area and then keeps coming back and keeps wrapping around and around and around, right? So this is why when you multiply two positive numbers, which is 1 million and 1 billion, you are actually getting a negative number, right? So how do you correct for this, right? First thing is to recognize that there is a problem. So when these numbers are pretty big, you need to actually recognize that there is an issue, right? Now the next thing to do is to identify, would this result fit in a long, right? So if I say long and I do this again, right, again this number is a little bit too big for a long as well, right? So this number doesn't seem to fit here. Now let me convert each of these numbers to longs. Let's see if this makes a difference. Right? So if you look here, what has happened is I've actually converted both these numbers to longs, because what has happened really here is without the L, each of these. So actually, let me do it this way. Let me create a V. I'm going to say 1 0 0 0. Okay, so that's 1 million, and let me make it do it with variables, so it's actually much easier to understand what's actually happening, right? So if I say I'm multiplying these two, what Java is going to do is Java is going to see this is a int, it could take the value 1 million, and that's fine. This is also an int, it can take the value 1 million because it's the same number, right? It multiplies them. When it does an integer and integer multiplication, the answer is an int. So here Java has seen that the value is an int. What's the value after doing the multiplication? It's this negative number, right? That we shouldn't get. So the answer is a negative number. So even though we are saving it in a larger value on the left hand side, Java has kind of not taken this into account. It's first done the multiplication and then it finds a value, and because this value, that is negative 727379968, will fit in a long, it happily just assigns it to the long, and there you go, right? So actually correct for this, the better way to do it would have been to either define this as long and now run this, or if you weren't working with these numbers, and sorry, if the variable, and you were working with numbers directly, so you say 1 million L L. So actually let's try it. Let's do it with 1 L and 1, that means this is a long integer literal and this is just an int literal. Okay, let's do it with both of these and see what happens, and you get the right answer, right? Because what Java has done here is, again, like these type promotion rules that we were talking about up there, it has looked at the entire expression. It has seen that the left one is a long, the right one is an int, so it promotes this guy to a long. So it actually in memory would change this to a long data type, and then it does the multiplication, and then your answer is actually correct, right? So this kind of stuff is really, I mean, it can get really confusing when you have to do, you know, formulae which are fairly long, like, you know, I mean, like even a compound interest formula, for example, which is a lot of, like, you know, things separated by brackets or whatever. Whenever these values are pretty long, you will find that it is better to break everything down. So take these numbers and break them down into separate variables, just like we've done here, and then write your entire expression. And even then, what you could do is you could actually do sub expressions. So you could do, like, you know, area part 1, and you could say like pi into r, and then multiply the the answer of that by r, right? So you have to be very careful when you're working with these fundamental data types or primitive types. I think a lot of people gloss over this, and then, you know, you may not understand what's happening. So I think if you follow these rules and examples here, I think you should be sort of in, you know, I mean, you shouldn't have a problem, right? So thank you for tuning in, and see you in the next video. Thank you.